Here we go. I've started recording. I want to welcome folks to the Autodesk Design Challenge kickoff. This is a very cool project that's being sponsored by Autodesk and their Fusion 360 educational design team. And so we want to thank Autodesk for sponsoring us with this and giving us the technical assistance, giving us the assistance of Alex, who is online with us. And she is going to be your student ambassador support person on this thing. My name is Randy Schuster. I'm one of the professors in design technology, and I'm sort of the project manager for this design challenge. And so there we go. So that's our introductions. I'd like to give you a little bit of an idea about what the design challenge is about, the purpose and the intent of it, because it's a little bit different than what you'll see in some. This is a real world design challenge. The actual challenge is a product that challenged me as a designer many years ago, before we had the tools at our disposal that Fusion 360 gives us. And I spent 2 years, disastrous years, working on this problem and getting it fixed so that this product would work well and consistently and right, in all facets of operation, because the product is important to the protection of our potable water system. Now, it happens that this was the best product on the market. It still is. Years later, it's the best product on the market. I'm going to give kudos to Watts Ames for the development of this product in the 1980s and early 90s. But our job is now going to be to update it to a more current standard, because it hasn't really been changed since the days when I worked on it. All right. So if you can think about it, a design challenge in the workplace isn't a contest. It's a collaborative effort to create the best product for the client. Now, this is going to be kind of a contest because there's going to be teams. Each team is going to be able to win a phase. But in the end, our job is to create the best product that will protect the water system of California. All right, so that's the purpose and intent. So I want to show you just really quickly. We've got this cool flyer. To register, you can use the QR code, or this is just an image, or you can click on this. All right, and so we'll be giving you all this information, and it's there for you. And I'll put the registration on this information from the calendar. But what you'll see is that there's 4 phases to this, and each phase you can join or not join. Each team, and a team can be of 1, 2, or 3 people. All right, and the teams can change in between as you go. So there's a part 1 modeling that lasts until October 23rd. Now, the modeling is very simple. If you've done the first 8 weeks of Intro to AutoCAD, you're actually ready to do the modeling. And you won't need all of this time. So if you decide to join on the 10th or the 12th or the 15th of October, you are welcome to do so. You do not need to sign up today. You can get in whenever you feel like it. So there's an actual 3D modeling portion in Fusion. And then there's a portion where we tell you about how your model is supposed to work and load cases. And that will have its own little bit of technical support. It's really just pointing at parts and saying what the forces and pressures are like on those parts in Fusion. And then you let Fusion do its job to do a design. Once we've done that, we actually have to do a performance analysis where we'll tell you some things that might have gone wrong, and you'll get to revise your design again, and then you do your final design presentation. And this is very similar to what happens in an actual design development process. And the goal of Fusion 360 is to put that all into one piece of software so that you can model the whole process without having to wait and do things in a very long, laborious, step-by-step process. Okay, so that's what we've got. I want to show you about what the outline for the project looks like. And essentially, there's 4 parts to it. There's a modeling challenge, which you'll see here. That's week 1 to 3. And as I said, the modeling itself is very quick. We'll show you the actual requirements of what you have to do in a moment. Then there's a little bit of design work to make sure that your model meets a set of requirements. And so you'll just change your model a little bit, and you'll learn that Fusion 360 has tools to allow you to do that quickly and easily. And that's where we'll apply some loads and things like that. Then we're going to do a redesign challenge, and then you get to do a final design. We'll show you what the output looks like for all of those things. So here's the structure of it, and there's a link to this thing so that you can look at that. I want to show you what the product is. The product is pretty simple. This is a check valve. A check valve, and I'm going to zoom in on part of it. A check valve has a base that seals, we call it a sealing ring, and a clapper that opens up to let water flow one way and not flow the other way. So in this case, this is called a cam clapper or a swing check, because the clapper opens by pivoting on the pin. Okay, so this part here swings out. One of the things that you'll be able to do if you want to spend time is actually make an animation of that. Fusion 360 allows you, after you've made your simple model, to make a nice little animation of that so you can show people how it works. So if you have a team member that wants to do that, that's really cool. And you can see the clapper is essentially a disc with a little rectangle, and there's a pin that goes through it. Now, you'll see that nothing really lines up here. We do that on purpose. When we give you this information, we do this on purpose so that you can't just cut and paste our stuff, okay? You have to make your own model. But there are some important things. This dimension right here, this 4-inch, that's where the water flows through. That's a fixed dimension. It has to be 4-inch. You have to have that much opening for the water to flow through. This 6-inch dimension is fixed. It's got to fit in through a hole and lock into a part of the valve that you're going to see in just a moment. Okay, those are the 2 really fixed dimensions, as well as this 2-inch dimension, because that fits in the valve that this belongs to. After that, the numbers get, you can play around with them a little bit. This 4 1/4 is so there's a little overlap so that it can seal. It has to push down on that part. Okay. This distance 2.59 is not fixed. You can vary that a little bit if you want to, but that's a good starting point. And this 2.88 is also, you can change your design if you want. That's not fixed either, but it gives you a place to start. And this 0.95 and this 1 are also estimates for you to start with. It does not have to be that. Your design can be different, as can this thickness 0.81. But if you're trying to start a model and get something started, these are starting points for you. Now, your requirement is to make the model of each of these pieces and put it together. It's called a solid model. And Alex has some videos that show you exactly how to do that using your basic drawing commands that you know in AutoCAD. Or maybe you know them from SketchUp. Or maybe you know them from Inventor. Or maybe you know them from SolidWorks. Or maybe you know them from Rhino or Vectorworks. All of those programs set you up to use Fusion very easily. And Alex is here to help you understand how to do that. And you'll see that she's available at certain times. We'll give you that information. I think Alex is always available from 3 to 4 on Tuesdays and Thursdays. And then there's other times where she's available too. Okay? So you're going to make this model, and then you're going to make some simple drawings like this, which Fusion almost makes automatically for you, which is kind of nice. So that's the design requirement. We're going to make a check valve assembly that is an up-to-date modern design. And that's about the only requirements that you've got. You can pick the material, you can pick the manufacturing method, you can make it expensive, you can make it cheap. We'll probably want one that's cheap. You should know that there are thousands of these made each week at a factory in Woodland, California, not far from us. Thousands each week. So you can imagine if you can save 10 cents, that's 10 cents times thousands each week. That's a significant savings to the manufacturer, which means a savings to the people of California that use these products. Okay? So once we've got that, we've got some resource materials because your presentation can be far more complex than just the very, very simple thing that we want. And the goal on a design challenge is to learn as much as you can about the product. So the very, very basic entry level of the challenge, you can make a 3D model and you can make some design prints. And that's 3 weeks. And then in the next 2 weeks, you can learn about, trimming some parts off so that it opens up a certain amount and stops and carries some loads. You can take 2 weeks to learn that. But if you really want to show that you're a high-level designer or want to be a high-level designer, you can look at the product itself and learn about it. So this is from Watts, who makes this product for real. Okay, this is the product. It's called a 774 Backflow Preventer. So you can learn about it from Watts and figure out about it. And even more, you can see a YouTube about the product itself.
And number 4, test cocks. The number 2 check can be loosened by placing it.
Like right there, you can see that's the part right there. That's what we're making.
Cannot be unthreaded by hand.
That's it. There's another one.
The arm against the notch found on the check clamp.
There it is, opened up.
Checks found in the 2.5 to 4 inch modules can be opened by hand.
There it is, right there.
Begin your inspection by cleaning the check module with water.
And you can see we're doing a kind of simplified version of it. That's okay. This tells you about why this product is important. And it's from the EPA. And when I first started working for the company that makes this product, this was the very first thing I had to read. I had to read this manual. And it's 52 pages long, but you can get good at reading or you can skip it. And here's a shorter version from Watts. It says why it's important and how it works and all the different ones. So we've got a lot of information for you, and you can include a lot of this in your presentation. Now, what is the format of your presentation? You can make it any format you want. We're going to give you, once you've signed up, we're going to give you sort of a checklist. And as long as you include the items on that checklist, I've got a 3D model in Fusion. I've got some drawings. I have a load case. I have. You can present it any way you want, and you can put as much material in it as you want. As we look at each team's work, we are going to award high-level certificates, the winner, to the group, the team, or the individual that showed the greatest depth of knowledge and effort and technical expertise that there is. Okay, but the end goal at the end of this is not to have won all these things, but to have been part of a process that created the best product possible. So let me show you just really quickly some presentation samples of how these might look. So Alex on this one used, I think it was a PowerPoint type thing. And you can see that there's lots, she put in, this was for a whole class, right? But let me get down to the part where there was a technical design to do. So here was a technical design that had certain requirements. So this is where you would talk about what is a backflow preventer, and what does it do, and what are the requirements, and what does it have to fit in. And this would be where you got your background information. And you can see they're just very cool pictures that catch your eye. And more research. So this is more research. And then it's always good to add hand sketches about your concepts and your ideas of how you're going to design things and how you're going to go about putting them together and what's important. Sketches are very, very, very important. And then there's your preliminary sketch work. What does it look like, and what are you thinking it looks like in reality? And then there's a little bit about, can I make this do using what we call primitives? If we can use primitives, that gives us a very easy modeling methodology, and it allows us to use what's called parametric modeling, that we can change sizes and things later on. So this thing about primitives will tell you about if you decide to join in and join on. Okay, and then you create your final model, make a quick drawing. This comes right out of Inventor or Fusion. And then we show the manufacturing method. Now in Fusion, we're going to take 2 or 3 steps before we get to this part. Okay, and then this was the actual manufacturing of the product, how you would actually cut it out. So there's an example of how you might present this. Just in a PowerPoint, you could use a Prezi, you could just use a PDF of your work. But all of these, any method that you choose would be perfectly usable. So there we go. The last thing I need to put on here that I see is your entry form. And so my apologies for not having the entry form on there already. I'm going to put it on right now. And you're going to watch me as I do it. So if you go to the entry form, you'll see that all we ask is your name and your W number. what skill set you've got. Now, you don't have to have all of these. You could have some, you could have multiples. Which part of the challenge are you most focused on? Okay, you don't have to do the whole challenge. You can do part of the challenge. And then what type of team do you want to be? Do you want to do this just all on your own? Do you want to be part of a team? Do you already have a team that you put together? You submit this, and then we'll contact you with a bunch of detailed detailed files that help you get going, information on how you can contact me, your project manager, Alex, your design tech assistant, or Autodesk. Autodesk has other design tech assistant resources for us too. Okay, so with that, does anybody have any questions about what the program is like and what the challenge is like? Okay, then I'm going to stop the recording. I'll make this available in just a